it represents vertical shift. So the way that I define Q under the trigonometric graph is the same way with the quadratic function. It's also the same with the remainder of the algebraic function. So we'll say here, Q is a value that determines the vertical shift of, right? Remember, as I told you, when it comes to a trigonometric graph, something has to be shifted, okay? So there's a specific graph that has to be shifted. Now, the same concept applies to the quadratic function. There is a graph that is shifted like Q units. Now, I'll just give you a general formula of that graph. The general formula, it will be, let me use y equal to ax squared. Okay? So, any graph of the form y equal to ax squared can be moved up or down by q units. Okay? If q is 0, it means we are dealing with a graph of this form. Right? If you have a turning point at the origin. Okay? So let me add here. Instead of q, so that's e. Then f. So this will be f. Alright, can you just do me a favor, because I'm just realizing now that I need to tell you something very important. Right? Let me talk about Q, then I'll go back and talk about the turning point. Right? So I'll give you the coordinates of the turning point. It's also important as part of the properties. So let's make this G. Okay? Sorry for that. Let's make it G. Then the other point which I'll go back to talk about, I'll make it F. So let's change that to G. But with your book, if you want to keep it as F, and then the turning point, you put it as G, that's fine. It's your book. Right? So for me, I'll make this. This will be my G. Right? So, right. So the general graph that's shifted, y equal to ax squared. Right? Now, if Q is greater than 0, the graph of, or rather, let me say, graph of y equal to ax squared is moved upwards by q units. Okay. Also, if q is less than 0, the graph of y equal to ax squared is moved downwards by q units. Okay. Right. So when you talk about vertical shift, right, make sure you are aware that something has to be shifted. And you need to know what is being shifted. Okay, so the general equation of the graph that's shifted is y equal to ax squared. The general equation of the graph that's shifted is y equal to ax squared. It is a quadratic function. Okay, this is before the vertical shift. All right. I think I'm done. Let me go back to the turning point. Yeah, I'm just going to add that here. So for me, this is going to be F. So turning. Okay, let's say coordinates turning point. Coordinates turning point. Coordinates of the turning point. Right. In grade 10, your turning point, if by turning point I'm referring to where the graph stops increasing or decreasing. Right? The graph of a quadratic function has got two turning points. Right? So if I sketch it like this point here is a turning point. Like I've spoken about this before when you're talking about the trigonometric graph. If I sketch it like this, where you've got the maximum turning point, right? The turning point is going to be a common point. Okay. Now, if you involve vertical shift, it means the graph will move up, which means the turning point won't be at the origin. Okay. But the basic graph y equals ax squared, you have a turning point there. Now, along the x-axis, the value of x is 0. Along the x-axis, the value of x is 0. So in grade 10, the value of x at the turning point is always a 0. But the value of y is not always a 0. So the value of y is going to be given by q. So q is the y-intercept of the graph. To go back to the general equation, remember, yesterday I spoke about the general equation. It's y equals ax squared plus q. So this q here, it is the y-intercept. It is also the value of y at the turning point. It is also a value that determines the vertical shift. Q is 0, then the basic graph y equals ax squared. There's no shift. Okay? But if Q is greater than 0 or less than 0, then it means the graph was shifted. So the turning point won't be at the origin. So the coordinates of that turning point are going to be x is 0, y will be q. Always in grade 10. Okay? So you just have to identify the value of q from the equation, and then you can be able to write down the coordinates of the turning point. So the x value is always 0 because the graph will never move away from the y-axis. And along the y-axis, the value of x is 0. Okay, that's very important for you to know. Along the y-axis, x is 0. Okay, so the graph can only be moved up and down along the y-axis. Therefore, x will always be 0. But q can change. Okay. Now, this is important when you are sketching the graph, which is something that I'm going to start with during the course of this lesson. Right? So, for that, I think I have to start almost everything now. Right? Then, we have got a question. Right? And I need you to be aware that for the trigonometric graph and the algebraic graph, like the quadratic function, including the hyperbola that we'll do later and the exponential, there is no horizontal shift. Okay? In grade 10, we don't discuss horizontal shift of the algebraic and trigonometric functions. That is done in grade 11. Okay? Now, in grade 11, just to give you more information, this turning point, okay, its value will no longer be x because we will be able to move the graph to the left or to the right. And the equation, the general equation will change. It will become slightly more complex. But that's for next year now. Right? Okay, so let's move on to sketch. Right. Now, Since you've already sketched the trigonometric graph, right? Means you have got exposure to sketching. So I don't expect you to struggle with sketching the quadratic function. It's not as complex as the trigonometric function. Right? So let's just do an example. Right? Then I also need to give you one question as a class exercise on the linear function in terms of sketching. Just now, let me just do this example. Right, let's sketch the graph of f of x equal to the graph of f of x equal to x squared. Right. This graph f of x equal to x squared is the basic graph of a quadratic function. Right? F of x equal to x squared or y equal to x squared is the basic graph of any quadratic function. As much as the trigonometric graph has got basic graph, y equal to sin x, y equal to cos x, y equal to tan x, the quadratic function also has a basic graph, which is this one here. Right? So I'll stay here, basic. Right. What I'm going to do, since I'm just starting I'm doing this for the first time, I'm going to draw a table of values. Right? For x values, let's say from -4, okay, I can do -3, okay, -3 to 3, okay. You can use the table values on your calculator if you want, but I'm going to do it manually, okay, because I'm starting. So I'm going to have my table. Remember, f of x is y. Okay? At this stage, I don't expect anyone to get surprised. See me writing f of x there, and there is no y, and then you ask, where is y? F of x is equivalent to y. So I'm going to sketch from -3 to 3. Okay? Now, when you write a test, you won't get a mark for drawing the table. Okay? There's no mark. That's why it's wise for you to master how to use the calculator to do the test. So if I substitute x equal to -3 there, I'll get a 9, then a 4, a 1, right, 0, a 1, 4, and a 9. Okay, so I'm sketching the basic graph here. Right, then let me move on to the next page. Your calculator can give you this table. And then you just draw your Cartesian plane, you calibrate it, you plot the point, join the points, and then you're done. So I'm going to do that on the next page. So just remember, this is the basic graph of a quadratic function, the one with a minimum turning point. Okay? If it has got a maximum turning point, then there will be a minus there. Remember, I defined the meaning of the value of a in the general equation. Y equals ax squared plus q. This a here, it is the one which determines the shape of the quadratic graph, whether you have a minimum turning point or you have a maximum turning point. So here a is positive. So when I sketch this graph, it's going to have a minimum turning point, right? So let me sketch it. Okay, so I've got x equal to negative, so if I say here -1, you must use the ruler. Okay, you can put 4 here, but I'm not gonna include 4. Right? Then I put well, let me make this one 2, 4, 6, 6. Then 2, 4, 6, 8, and then 10. Okay, so let's plot. Okay, so when x is 0, y is 0. When x is negative 3, y is 9. So that will be somewhere there. Then minus 2, that will be 4. Then minus 1, obviously that's going to be 1. So that will be somewhere. Then 1, 2, which is going to be a 4. And then 3 is going to be a 9. Okay. Then, right? So I plotted now. Now just have to join the points using freehand. Okay? No ruler. You don't sketch it using a ruler. So if I sketch this, it will look like this. Okay, it will look like that. And so let's put the x, the y. Okay, now on this graph, we have to state its domain, its range, right? The turning point, and the equation of axis of symmetry for the graph. Let me start with the domain. Please be aware that the domain is not from -3 to 3. Okay? It's only that I only selected part of the domain to sketch this. Okay? But the domain is x is an element of real numbers. So you're starting from negative infinity up to positive infinity. Okay? Then the range, right? Your minimum value is going to be the value of y at the turning point. If it has a smiley face like this. So the minimum value of y is going to be 0. The maximum is going to be positive infinity. So if I use interval notation, the range with the y is an element. I'm starting from y equal to 0 up to positive infinity. And then you put a circular bracket. The moment you have got infinity or minus infinity in your range, you use circular bracket, not square bracket. If you put square bracket, the answer becomes incorrect. So that's the domain, that's the range of the graph. Okay? Remember, this 0 here is a Q value. So always your range is going to have the Q value. For this graph here, Q is 0. So we're going to have a 0 there. Right? Later we'll sketch a graph where there's vertical shift as well. Right, so we have got that. Then, yes?
Why can't you say why also
Okay. This caters for that. Okay, I can't say y is an element of real numbers. By writing this, I'm saying the values of y start from minus infinity up to positive infinity. So it's different now for y. Y is not starting from minus infinity. Y is starting from the turning point, going up. And the value of y here is 0. Also, the value of q here is 0. Yes.
do you have to label it?
Yes, we have to label it out. That's something that you have to do always whenever you sketch. Okay? So for the range, we don't have to write y is an element of, by y is an element of real numbers, we are saying y takes all the values, which is not true for this graph. Okay? You will never get a value of y that's negative for this graph. Therefore, we can't say y is an element of real numbers. But for x, yes. We're starting from negative infinity towards positive infinity.
Sorry for the disruption. Can I please?
Okay. All right. So then I need the equation of axis of symmetry. The equation of the axis of symmetry. Okay, just allow me to write it as equation of axis of symmetry. So I can write this EQS, okay, or EAS. Right. So EAS stands for equation of axis of symmetry. We are just using that acronym for our own purpose. That equation is x is equal to 0, which is the equation of the x-axis. Okay? Always the equation of the axis of symmetry is x equal to 0. In grade 10, it doesn't change. Right? Then, what else? I think that's it. Our turning point, okay, we can add it. Turning point is that x equal to 0 and y equal to 0. Right? For this one now, x is 0 here, y is 0. Are you following me? Yeah, it's not difficult. Okay.